One of the most commonly asked questions I usually get when it comes to solving any physics problems, especially force problems, is where do I begin? So in this video, over the next few minutes, I'm going to show you how to use a very simple framework to solve any force problem, no matter how hard it is. The first thing you want to do is, of course, just read the question. So we're actually going to use this as the example question as I walk you through the framework, so that way you have some sort of reference to look at and follow along with. The first thing you want to do is, of course, just read the problem. Okay, so let's go and do that. You pull a box with 100 newtons of force using a rope angled at 20 degrees above the horizontal. There's a frictional force of 25 newtons. Determine the acceleration of the box. The mass is 20 kg. So the first thing after reading the problem is to, of course, draw the FBD. So you want to draw an FBD, a force body diagram, and I made a separate video covering how to do these as quick as possible. So to draw the FBD, we're going to use a dot to represent the box, and on the box is, of course, the force of gravity that we call the weight of the box, that I like writing as mg. The second thing I want to draw is, of course, the rope, right? The rope is a tension force, and it's at an angle of 20 degrees above the horizontal. This is the horizontal, and so 20 degrees above that is going to be the tension force, okay, just like that. And notice how I'm not putting any numbers. The next thing I'm going to draw is the frictional force of 25 newtons. And so this 25 newtons is significantly less than this 100 Newton force that's pulling the box. So in other words, the tension force is definitely bigger than the frictional force. And so I need to make it such that it looks like it's going to be smaller, okay? And looking at this, the diagram is incomplete because I can tell that there is in fact a net force downwards, so this would mean that the box is accelerating downwards to some degree, okay? Now there is a little bit, there's a component of tension that points upwards just like that, okay? That's actually holding the box up as well, but you still also need a normal force, okay? Because it's going to be, ideally, presumably, it's going to be on a surface, the box. And so there's going to be some amount of normal force that we're going to call N. Okay, so that does it for our diagram, and just to kind of show you the components of tension, there's going to be a component of tension that's in the x direction. There's going to be a component of tension in the y direction. And again, this component that we're going to call Ty is going to add to the normal force such that it balances out mg. So that way there's no net force vertically, and it should not be moving through the desk. Okay, and then in the x direction, Tx, the tension in the x direction, should be bigger, as you can see, than the frictional force, because there must be a net force this way, and so therefore there's going to be an acceleration this way. That's what it's asking us to find. Determine the acceleration of the box. Okay, so in the previous video, like I said, we covered how to do this, and that's what I mean by, like, doing this accurately is like half the problem. If you can just do this right, it's going to save yourself a lot of time and a lot of trouble later down the road. The next step is to actually go ahead and sum up the forces. Now I'm gonna sum up all the forces in both directions in this case. Now you don't always have to do that, and by that I mean, because we're determining the acceleration, I know that the acceleration is only going to be in the horizontal direction. So I want to start off by doing F net in the x direction is equal to ma. But again, just for the sake of this problem, I'm going to do both directions. So F net in the y direction is equal to ma in the y direction, and this is going to be in the x direction. Okay, and so again, what does this mean? What does F net x mean? It just means the sum of all the forces in that particular direction. So if you look along the x-axis right here, you see that we have one force here and two forces here. And notice how they're pointing in opposite directions. So this is really going to be Tx plus negative friction. Okay, so again, the net force is going to be Tx plus negative friction, which is the same thing as writing minus friction, is equal to max. Okay, so there you go. There's one of your equations. And then on the vertical side, on the y side, we're going to do the same thing. The net force in this case is going to be these two vectors pointing upwards, so Ty plus n plus negative mg. Okay, so again, Ty plus the normal force, and then plus negative mg, which again is the same thing as just writing minus mg, okay? And that's equal to m acceleration in the y direction. Okay, cool. That's pretty much 90% of the problem. The other 10% is really just math, right? It's just plugging in the numbers, rearranging, and solving for what you need to solve for. In this case, we want to solve for the acceleration in the x direction. That's what they're asking us for. And so when you look at this equation, you have to ask yourself, can I solve for the acceleration in the x direction? Do I have tx? Do I have the force of friction? And the answer is yeah, we do. We in fact do have the tension in the x direction. Okay, so this was 100 newtons tension, and we also were given the angle, and so therefore we can find this x component. And they also told us that friction was 25, and so we do in fact have these two numbers. And then we also have a mass that was given to us, that was 20, and so we can also plug that in. So in this case, we didn't even have to use the x side, but sometimes you're going to be missing two variables, in which case you're going to need to use both your equations and do a little bit of substitution and problem solving. Okay, so let's go ahead and finish up this problem here. That's my two-step framework, by the way, on how to solve any force problem. And the last step would just be to actually just plug and chug, right? So again, Tx is going to be this horizontal component. This was my angle here. And so again, to find that horizontal component, you're going to multiply the hypotenuse by the cosine of theta, because this is the adjacent side. And so we're going to say 100 cosine of 25 minus the frictional force, which in the problem told us was 25, is equal to the mass, which is going to be 20 kgs, multiplied by the acceleration. Okay, and then you can go ahead and plug this into your calculator and solve for A, and you're going to get 3.28, and that's going to have a unit of meters per second squared because it's an acceleration. All right, that wraps it up for this video. In future videos, we're actually going to cover significantly harder problems, and I'm going to show you how you can use this simple three-step framework to solve even the hardest of problems. All right, take care. I'll see you in the next video.